Okay, good afternoon, everybody. Can everyone hear me? Yeah, cool. My name's Glynn Bird. I work for IBM in the UK, and today's talk is entitled "The Serverless Full Stack." We'll define what these terms mean as we go along. I'll make the clicker work before we start. Right, I'm going to press the button instead. Right, so I'm a developer. I write software. I've been writing software for years. I'm a programmer. I like writing code. Now, the advent of the cloud has made it that my job has changed. So I'm no longer just responsible for the code that runs on some servers that somebody else manages. The advent of the cloud has made it easy to provision services, computers, computing power, databases, and so on, very easily. And my role has merged with an old role that used to be the system administrator. The sysadmin used to do the computers, and my code would run on the computers that somebody else managed. So this is the world of DevOps. And I didn't ask to do DevOps. It just became my role. I had to do DevOps, otherwise I'd be out of a job. But I didn't like it. I want to do code. I want to do more dev and less ops, in fact. And the cloud, the promise of the cloud is for me, is that I should be able to do that. I should be able to get back to doing what I like best, which is writing code. So we'll see throughout the presentation how using serverless technology allows you to get back to doing what you like best, assuming you're a developer. So this is the story of the cloud. Hopefully you know all this. Now, I'm old enough to remember the left-hand side of this slide. So in the old days, you used to buy servers from Dell or somebody. You used to buy a physical server, and they'd arrive in the post, and you'd rack them yourselves, and you connect them yourselves. And they would have nothing on them. You'd have to install an operating system. You'd have to define how they were connected. You'd have to install your software on top of them. You were responsible for power and networking and cooling and uptime and so on, all sorts of terrible things. Nowadays, very few people do that. Banks still do that, because they need to have their servers inside of their premises. But most people will rent a server in somebody else's data center. It seems perfectly sensible. Somebody else is going to do that for you. You rent a server, you lease a server. And not only that, you lease a small part of a server, a virtual server. You don't need a full server for yourself. You only need a small piece of it. So the size of the piece of computing you're buying is getting smaller over time. In the old days, you had to buy a server that lasted 3 years and then buy another one in 3 years' time. Now you can just rent a server for a week and then switch it off, and you only pay for a week's worth of computing. And then containers mean that we can spin up servers or small servers and run them for a few minutes and only pay for a few minutes of computing time. So the unit of computing that we're buying gets smaller and smaller. And it becomes easier and easier to spin up these units of computing, but they're still servers. They still have operating systems. They still have software on them. They still have security problems. You still have to worry about networking. You still have to make sure that they are up. Otherwise, your service is down. So this is where serverless comes in. I don't like the term serverless. It's a terrible word. What people really mean by serverless is functions as a service, as we'll see. Functions as a service. That's buying a unit of computing that's very small. But this term serverless has come around, and we have to go with it. What they really mean is there are servers. Obviously, there are servers somewhere. Somebody's looking after the servers. It's just not you. You don't have to deal with the servers. You never reboot anything. You never install anything. You never have to manage the scale. You never have to worry about how many servers you're going to need. So in that sense, it's serverless because you don't care. And that's quite good. From a programmer's point of view, I don't have to worry about it. I can write some code and throw it into the cloud and get somebody else to worry about it. So this is what functions as a service is. It's an extension of containers. So each of these functions is actually a container. It's using something like Docker or Kubernetes, something like that. And you write your work, the compute that you need to do, as a single function. So you don't have to worry about a web server or a queue anymore. You just write the function that would act upon an API call or something arriving in the queue. You just write the work that you need to do. Your code becomes actually quite small. And you can have as many pieces of work as you like, and you throw them into the cloud and say, when I need to run that function, I will tell you about it. I will tell you about it by calling an API call, by putting something in a queue, by changing something in a database. Some event-driven stuff will trigger one of these functions to run. Now, I might never run these functions, and then I never pay for anything, and that's a real plus point. So functions as a service means that you don't pay for low usage. You don't have to have a dedicated computer waiting for traffic to arrive, and then it doesn't arrive. You only pay for the compute that you use. So it's really good for low traffic applications. And it also, scalability is the responsibility of the platform, not of you. The code stays the same, and somebody else worries about the scale. They will spin up as many of these things as they need to deal with the demand. So, we need to build something. So, what the world needs is another social network. So, what I'm going to do is build a social network, but it's got a key, unique selling point, and that is, it's a photo-sharing website that is social, but you can only post pictures of dogs. And it's called Insta Puppy, and it's just like any other website. You log in, you get a username and a password, you register. So there's some sort of, you'll get an email, and you click on the email, the usual sort of thing. Once you're in, you put in your username and password, you upload a picture of a dog, and then you can share that with your friends, and you can like other people's. It's a very familiar story. It sounds like a terrible idea, but people have got venture capital for worse ideas than this. And look at that. What's not to like? And then here's my selling part. So then, of course, you can buy prints of these pictures, and there's a sales path going off, and you put your credit card in, and you get a picture in the post. So this is going to make millions, but it might not make millions. It might not work. Nobody might come, and I don't want to have to buy a load of computers or rent a lot of computers, and then nobody to use them. So this is where serverless comes in, because I can put my idea out there. If it works, then great. If it doesn't work, I've lost nothing. I don't pay anybody anything. To build something like this, I'm going to need some computing. And I've broken it into 5 separate sections. On the left-hand side, we've got a static file server, a normal web server. I need to serve out my HTML. It's going to be a web-based application, so I'm going to need some HTML, I'm going to need some JavaScript, some CSS, some fonts, the usual stuff that doesn't change very often. It only changes when I release a new version of it. And serving out static files is pretty easy. You could spin up your own web server and do it yourself if you want to, but we're going to find something to do that for us. Then we're going to need something to store the content that other people upload, the user-generated content. And that, if this website is popular, this is going to be quite big. So I need an unlimited file store that never runs out of space. And I only pay for what I need. So that's my unstructured data. I also am going to have some structured data. I'm going to have a table of users. I'm going to have a table of metadata about my pictures. I'm going to have a table of likes. I'm going to have a table of orders. This is very structured data with rows and columns, probably. So that's classic database material. I'm going to need a database. So I need unstructured data storage and structured data storage. I'm also going to need some logic. I'm going to write some code. Hopefully I'm going to write some code, because that's what I do. So I'm going to have some logic sitting somewhere. And this has got to scale as well. I'm going to write my code. It could be in Python or Java or Node.js, whatever language I choose. But the logic might decide, has the person put the correct username and password in? If so, let them into the website. If not, say, sorry, wrong password. And finally, the last piece, which I could use the database for, but I'm going to pick a different sort of database for this. This is a session store. So you'll be familiar that when you log into a website, you get a cookie, and that cookie refers to a piece of data that's stored on the server side called a session. And usually that needs to be retrieved every time, with every request the cookie comes in. The server side has got to work out, is this session valid? It's got to load that data from a session store. So I could use the database for that, but I'm going to pick something else. Right. a few years ago, this is how I might have done it. If I had a brilliant idea for a website, and I thought, let's just put it out there, what I would do, I'd go to a cloud provider like DigitalOcean or something like that. $10 a month gets me a server. And I can choose which operating system I want from a list. It's not very hard. And then I have to install the tools that I need. If I need Node.js, I'm going to have to install Node.js on Ubuntu or something. And because I've only got one server, I don't want to spend a lot of money. I'm going to use that server to store the uploaded content as well. Might as well. It's all included in the price. And if nobody uses it, I don't want too much expense. And because I need to serve out content, I'm going to put my web server on there. So I'm going to install Nginx or Apache HTTPD or something like that. And I'm going to need a database. So I'll put that on there as well. You know, pile everything. These servers are quick enough to manage it. For a low-traffic website, this will be fine for your purposes. And I've got a pretty low cost, $10 a month. That's all right, isn't it? That's nothing. I plug it into the internet, and that's fine. Now, this is classic DevOps territory, because I've taken on the responsibility of doing the code. There's some code somewhere in here, in the web server or in the application stack. But I've also got to patch the operating system. I've got to make sure this is up 24 hours a day. I've got to work out what the networking configuration is. I've got to back up the database. I've got to do all of these administrative tasks. And I'm the developer. I don't care particularly. I'd like somebody else to do that if that's possible. It's also, this is an English expression, I don't know if it translates, all your eggs are in one basket. So this means that if that server is down or any of those services fail, your whole website's down. And nobody gets to share pictures of their dogs, which is terrible. That's terrible. The way to do it is to start breaking them out into separate pieces. So let's move the database onto its own server, because we want dedicated computing for our database, dedicated computing for our application. This apparently is the way to do it. So I move my database. Now I've got two servers. I've doubled my cost, because I've got two pieces of computing. And I've also doubled the amount of management that I've got to do. I've got two sets of operating systems that need patching. And I've got another piece of networking. Perhaps this is private networking between the two at the bottom here, this connection at the bottom. And this is public networking. This is private. So it's becoming a bit of a headache. And actually, I haven't made it any more reliable. I've made it less reliable than I did before, because if either of these two things go down, then my system is down. So my availability has fallen. I've made it worse and doubled the headache for me. So this is a bad idea. Don't do this. The way to make things work and be reliable is to have lots of them. So I'm going to need a load balancer. I'm going to need multiple copies of my application server. And then I'm probably going to need 3 or more. So now I've got at least 3 servers. I've got a load balancer. I haven't even dealt with the storage, because we're going to need 2 lots of storage for 2 lots of every database, 2 lots of the session store, 2 lots of the file store. You can see it's becoming rather complicated. And this idea might not work. I know that's sad news, but my idea might not become popular. And this is suddenly my expense and my management has become quite high. So the purpose of this talk is to say, don't do it like that. I want all of these 5 things to be achieved with no fixed assets, with almost no cost to me, preferably 0 cost to me, where somebody else manages the resources, not me. And I just program it, and I take the money, ideally. So, static file server. This is the easiest one to deal with. And I'm not affiliated with any of these organizations. I'm just saying, here's one way of doing it. So I need to serve my static HTML, CSS, JavaScript. And I said to you, it only changes whenever I release a new version of my code. Well, what better place to put it than to tie it into my GitHub repository? So I put all my code, my HTML, my front-end stuff, onto a GitHub repository. I go into the settings panel, I tick the GitHub Pages box, and then suddenly my website is served out automatically. My repository is served out on the internet. I can have a custom domain name, I can do HTTPS and all that sort of stuff, and I'm not even running a web server. I'm not managing it at all. And it's served out by their CDN, their content delivery network. So it's spread around the globe. It goes nearer to my users. Nearer means faster for distributed systems, so that's brilliant. And I haven't touched any Apache configuration or any Nginx configuration. The same applies to Netlify. I haven't used it myself, but it's a similar service. It behaves by the same rules and has all sorts of features. And it's continuous integration. I can do all of my source code control, and when it goes live, when I merge into the master branch, my code goes live automatically. It's beautiful. Really simple. And you don't have to have just static HTML. If you build your websites using a tool called Jekyll, that comes out of the box with GitHub pages. You can break your headers and your footers into separate pieces. Really clever stuff, but dead simple to do. So check out Jekyll if you get a chance, if you haven't already. That's what I use to power my own website. So now another easy solution for this. This is the user-generated content. I need an unlimited file store because it should never run out of space. It needs to be super reliable, always on. It needs to store data in multiple locations so that I never lose anything. And object storage is the problem solver here. It's not new technology. It's not glamorous, but it is really, really reliable. Amazon S3 claims 9 nines, 99.9999999. Super, super reliable stuff. IBM has one too. You can choose how many copies of data you want, whether you want it in the same data center or spread across different data centers. Very, very simple to do. Just throw your files on there. You will never run out of space, and it's almost guaranteed to be always on. If I tried to do that myself, I'd just end up in a bad place. They're also, again, tied into a CDN. So if you want to serve out those assets, and you want those assets to be nearer to your users, then ticking a box in one of these object storage services means that it's served out through a CDN. Again, you don't have to write any code. It's just done for you. And again, no web server configuration, no backup, no nothing. So now we get to the application logic. I've got to actually do some programming somewhere along the line. I'm going to have to write something. So I start breaking my application down into pieces. It's like building microservices. I've got an idea of what my application wants to do, but I have to break it into small API endpoints, if you like. So this is authentication. I'm going to need a registration path, something where people click a link on an email, some means of logging in, some means of logging out. I also might have password reset and other things, but this is a minimal viable product. So this is my authentication endpoints. 4 endpoints, that's all I need to make this thing run. And I need something to do with photographs. I need some means of uploading pictures, favoriting, sharing, resizing images. Because often you will upload a big image and then make a thumbnail of it and store both on your system. So I've got my posting endpoints. And then my money-making stuff, I'm going to use an external purchase path, something like Stripe or PayPal. But I'm going to need some API endpoints to receive the data when it's come back from the payment path. So a few API endpoints there. So you can see it's not very difficult. I've got a little bit of programming to do, but it's not a lot. And I've broken down my database, my application logic into a handful of endpoints, API endpoints. And if I code these as functions, I can deploy them to a functions as a service provider, and then it can run them whenever I want to. So this is how you would do it. You break things down to very small pieces. You don't have to worry about the web server. You don't have to worry about how am I going to queue the traffic, how am I going to deal with concurrency, or how am I going to feed these things. Just build your code that does the work, and your code becomes very small and easy to manage. So how can I run this code? I could run it like this way, but we've decided that this is a terrible idea because I'm going to have to manage all the servers. Much better way is to pick a functions as a service provider. You give it a function, you tell it which runtime you want to run it under, Node.js 7.1, and you give it the credentials to be able to write to one of your other servers. So in this case, the resizing function can write to object storage, and that's it. It doesn't see any of the other system. It's not connected to the database or to the session store or anything. It's just connecting to the object storage. So it's very simple, very easy to test, very easy to write tests for, very clearly defined inputs and outputs. Interestingly, I don't know what operating system this thing is running on. I'm just saying run this on Node.js 7.1. I don't even care. It's somebody else's problem. And the same applies to other programming languages, by the way. You could pick Python, Java, Swift, PHP, and you just tell it which version you're going to need, and somebody else sorts it out. And the key here is that these are short-running services. So these aren't like microservices which are running continuously, and you have to make sure that they're always up. These are short-running services that do one piece of work and then stop. That's a key difference. It means that you're writing code that just does one thing and stops. It means you're not so worried about crashes or memory leaks and things like that, because you're just dealing with one piece of work at a time and then stopping. So how can I deploy this? Well, you won't be surprised to learn that there's a cloud service for this. The market leader and first to the market is AWS Lambda. They power all sorts of things, including your Alexa voice-controlled assistants and things like that. It's all powered by serverless functions. They have their own developer advocates. I don't need to promote them particularly. They're doing quite well. But there are other solutions out there too. Every cloud has a functions as a service offering. So if you've got data in the Google Cloud or the Microsoft Cloud or the IBM Cloud, you're probably going to want to use the functions as a service provider that comes with your cloud, because you want your data to be close to the thing that's running your data, because closeness means speed in a distributed system. But also, it's not quite that simple. There are functions as a service providers connected to event-driven data. So Twilio, who do voice calls and text messages, they have an API that allows you to do that. They have a functions as a service offering. So if you're doing a telephony application, then you might want to connect it up to their functions as a service instead of putting it in a different data center with a different provider. Similarly, Iron.io, they're in the middle there. They have a queue as a service offering, and you can just connect a queue to some functions and just throw data into the queue. So if you're a customer of theirs, it makes sense to use their queue in there. So pick the one that makes most sense. The other aspect of this is that all of these are closed source proprietary systems that you don't have access to. You can't run them on your own machine. You can't test locally. So that is a bit of a disadvantage, apart from one, and one of those is Apache OpenWhisk, which is an open source project. With one command line, it will spin up a Docker container containing all of the things that OpenWhisk needs to run, and you've got OpenWhisk running on your machine. You can just feed it work. Not for production. Otherwise, we're back into the same position we were before, that you've got to make sure this thing runs, and you've got to manage it, and so on. But for development, it's very handy indeed to be able to reproduce an environment and work on it on the train, rather than relying on network connectivity. Shout out to IBM's Cloud Functions is based on Apache OpenWhisk, but it's not the only one. So Red Hat have one, somebody else has one. So there's multiple OpenWhisk as a service providers out there doing the same thing, so you're not locked into one vendor. So you can run it on your own machine, and you could switch to a different vendor if you wanted to. And just so you get an idea of how easy this stuff is, it really is very simple. So imagine you've got a function, a single JavaScript function in a file called hello.js. You install the WSK command line client, and you say, whisk action create. Create me a whisk action called hello, and here's my file. It's called hello.js, and that's it. It uploads it to the service, and then it's ready to run. That's it. Very simple. You change create for update. You can update a service. If you want to make it a bit more complicated, so actions is the same as functions in this world. So an action name can have a hierarchy. So we've got pick/resize. So we can use our API modeling that we did before when we broke our system down into various microservices. Then we can show that hierarchy here. So grouping things into packages is useful because they might share the same configuration. All the picture-related ones might all need to share the same credentials to write to object storage. So you only have to group those together in the package once. Also, in the green parameter here, we're specifically saying the version of Node.js we want. In the old one, I was just saying, this is JavaScript, you run it, I don't even care what version. But you might need 7.1.1 or something, so you need to pick the right, if you need to pick the right version, you can. And in this case, I'm also saying, here is a zip file with a bunch of code. So my function requires these libraries to run, so I'm going to give you the function and its libraries in a zip file. It's not much more work than just saying, here's the function. Again, I don't deal with operating systems or queues or web servers or anything like that, but I do have to give it does have to be able to run as a self-standing piece of code. And one simple trick here is if you want to make this an API endpoint, to give it a URL, just put web is true at the end, and you end up with the URL that you can call your code with and pass parameters it into. There is a full API gateway where you can create a fully featured, authenticated, rate-limited, enterprise-grade HTTP API. But this is a nice, simple way of just creating an HTTP endpoint for your actions. Really, really simple. And the code itself, the code isn't complicated, or it doesn't have to be. So this is a whole action, top to bottom. And it's, I'm cheating a little bit because I'm using an include from another file. I'm using a built-in library. But basically, the gist of this is it's using an external API to read the current price of Bitcoin. So when this function runs, it goes off to an API, says, what's the current price of Bitcoin? And then it writes that data to a database. So one of the triggers for you can use in OpenWhisk is time. So you could say, run this every minute, run this action every minute, and you've basically got a cron running in the cloud with no infrastructure for you, doing some work, writing to a database without you having to manage it. That's pretty cool. And it's 5 lines of code. All the rest of it disappears. You know, there's no web, it's a web-based, it's a web-based API. You don't see that. You don't see the queue that's running in the background. It all just disappears, and you just write the code. And then you imagine you writing the tests for this. It's really simple. You're just changing the value of args, the data that comes in, and you're looking at the data that comes out. It becomes a really simple black box test. So from our 5 components, we've easily made 3 of them using web-based services. So when I say serverless, I mean not using your own servers. So we're going to use a file serving utility like GitHub Pages for static file serving. We're going to use object storage for uploaded content. We're going to use a functions as a service provider like OpenWhisk or Lambda or something like that for our logic. That leaves 2 other things, and then we've got a full system. So we need a database, we need a session store. First of all, session store. So Redis is another open source product. I like open source products. They give me a warm feeling that I'm not walking into a dead end with my project. So Redis is an in-memory database. So all of the data is stored in memory. It is later written to disk, but you wouldn't want to rely on it. You wouldn't want to store your financial data in there, perhaps, because if you switch the power off, you might lose some information. But it is really, really fast. And really, really fast is what you want for a session store. So this is often used as a cache in front of a slower system, and it makes slower systems appear faster because you cache a piece of data, a bit like memcached. But it's much more than that. Redis is actually a fully featured database. It provides you with little primitive data components so you can create lists and queues and hashes, or it can behave as a key value store. In this case, we create time-limited keys. We'll say, here's a key that represents a session, and here's a blob of data that represents a user. Store that for an hour, and if I don't come back and look at it, delete it. And that automatically logs somebody out effectively. The database does the work for me. I can run Redis on my own machine. It's really quite small. You can build it, compile it, run it yourself. We don't want to do that. We don't want to run it ourselves. We want to get somebody else to run it. And you can actually run Redis in many clouds. It's one of those services that's so good that all the clouds tend to have it, perhaps with a different name. Compose.com is a company that IBM bought, and they offer all sorts of databases as a service. Redis is one of them. And what they're doing, they're not just spinning up a single single node copy of Redis that if it goes down, you've lost it. They're spinning up a multi-node resilient cluster of Redis that can survive a failure. So it's a service. You just get a URL and you start to write data to it, and it's stored in memory, managed by somebody else. As the database, I could pick any database. I mentioned earlier that I would store data in rows and columns. Normally, that's what most people do. They create a MySQL database or a Postgres database, define what the columns are going to be, define the data types, very strict schema, and then you would create rows in that database. And that's fine. CouchDB is slightly different. It's a NoSQL database. It's a JSON document store. That means I don't have to define the schema up front. I can just throw it a JSON document, a document that represents a picture or that represents a user, and it's just a blob of JSON. I don't have to tell the database what the schema is. So it makes it quicker for me to get started. Again, it's an open source project. You can run it yourself. This is a familiar story. You don't want to run it yourself in production, otherwise we end up in the same trap as we had before. You probably want to pick it as a service. So a way of running Apache CouchDB as a service is to use Cloudant. It's a database as a service. You just sign up, you get a URL, and you throw JSON into a document store. Very straightforward. Somebody else, we have operators running 24/7, making sure that this service stays up, so you don't have to. So you can just write the code. So there we have it. We have a fully serverless, full-stack system going from front-end to back-end. We're storing data, we're storing sessions, we're storing uploaded content, we're serving stuff out on a web page, and it would be wrong of me to not show you a demo. I must show you a demo, otherwise you're going to go home disappointed. And I don't want that. If I can remember where it is, that would be handy. Right, so here it is. It is served out from GitHub Pages. So, oh, you can't see it. That's why I can't find it. It's in the other window. How do I get to the other window? There it is. Right, so it's served out on GitHub Pages. So I don't have to deal with web servers or anything. It's just a website. I could put a custom domain name there, but I haven't. But I log in with a username and password. I'm going to have to type while I speak, which is never as easy as it looks. Put a password in. And when I log in, it's going to call one of my serverless actions to say, is this the correct username and password for this user? It says, yes, he is the correct username and password. Here, have a session. Store that session in a cookie. Your website's now live. It's a totally static website. There's no dynamic stuff at all. There's no PHP on the server side. It's a totally static website. And you can see my recent posts are listed. Lots of pictures of dogs. I want to upload a new one. So I need to drag and drop a file. I'd forgotten about this. This is going to be fun. Because the windows are back to front. It's left here and then right there. So here we go. So I drag and drop a file. It arrives there. I drop the file. And it gets uploaded to object storage at the speed of conference Wi-Fi. There it goes. It is uploaded to object storage. So this is the browser speaking directly to object storage. Now that's terrible. I've got write access to my object storage from my browser. But it's not quite that simple, because it first called a serverless function to say, hey, you know me, I've got this session, so I'm a valid person. Can you give me a one-time URL on object storage that I can use to write one object only and then kill it after a minute? So that's what it's using to do that. I give it a name and a description, whatever, and I click upload, and that's actually uploading the metadata, not the image. The image is already uploaded. And then it is uploaded. And I can render the web page because I can download the content from object storage in the same way. The object storage is also my file service for uploaded content. So it all works. And then if I log out, I will lose my session, and we're back to where we started. So I click log out, and we're back to where we begin. So it's an entirely static website with a database at the back end, with object storage, with a session store, and some serverless actions. And do you know what it costs me to run? Nothing. Costs me not. It gets no traffic. But don't worry, the traffic will come because it's such a good idea. But at the moment, it costs me nothing. I'm not paying. All of these service providers have a very generous free tier. You can use 1 million function calls to your functions as a service provider, and they won't charge you anything. You can, if you stay below the data storage limits of your chosen cloud database, they can charge you nothing. So it's very good for developers. And we're back to the beginning of the talk, the thrust of the talk, which was, I want to get back to development and not deal with servers. I don't want to deal with operating systems. I don't want to patch servers. I don't want to be woken up in the middle of the night to say web server 3 has got a bad hard disk. I want to just get on and program computers. And with serverless technology and using a combination of databases as a service, I can achieve that dream, finally. So I'm going to stop there and invite questions. Thank you very much. Yes, sir. Do you need a microphone for the questions? The roving microphone. Oh, but it's just for the recording, for all of our fans on YouTube.
Just like for microservices, for instance, when you have a rising number of moving parts in your application, you probably want to intensify monitoring of this stuff because you want to know when something fails, which part exactly fails. Right. Do you know of any good method or framework or product that allows you to have metrics or monitoring of these kind of systems? I guess there are
a lot of it all depends on which provider you choose, but they all know this and provide their own built-in logging services. So all of these functions as a service providers will provide logging, a logging bolt-on product. So OpenWhisk has Kibana based on Elasticsearch. Lambda has its own internal logging thing. I forget the name. But basically, the logs, anything you console.log or you print from your code will end up in some logs somewhere, so you can mine it.
Well, in this case, given that we chosen different cloud solutions for different parts,
right.
you took the database for one vendor and the things for from other services. Can you possibly aggregate all these things into one single point?
Yeah.
Maybe
I mean, you can actually employ an external logging as a service company. There are plenty out there. Okay. And then all of your services could write to the same logging as a service company, and then you've got aggregated logs for your whole service.
You have control over that.
But your observation is exactly right. Once you start breaking things into, my initial solution, which was one DigitalOcean box, it's very easy to know what's gone wrong because you can look at the system logs on one machine and work out what's going on. As soon as you go to a distributed system, even if it's your own computers, it gets way harder. It gets even harder when it's as a service offerings because you're relying on somebody else exposing the logs. And what's gone wrong can be a very difficult question. I suggest having really first-class logging and monitoring, definitely. Yeah.
Thank you.
Yes, sir.
There are many platforms.
Just one second. Yeah. The people at the back won't be able to hear you either.
Hi. There are many platforms like Buzz as a service, backend as a service, that are all or many of these service in one platform. Do you suggest you use like that, sometimes like that, or use different service for build?
I think if you use lots of, if you pick the database from Google and your queue from Microsoft and you're asking for trouble, actually, because any of the connectivity goes down and you're in trouble. Usually, that's not the way people do it. Usually, people will pick a cloud and even have a distributed system amongst that cloud provider's data centers. You don't often find people that. The exception is perhaps logging as a service. You might pick there's an external logging market leader that does logging. You know, you might use them for logging. You might use Twilio for telephony, where you want very specific tasks so that only one company does the thing that you want it to do. But for computing, storage, queuing, load balancing, you know, backup, you're probably going to pick all of that all in one cloud. And having stuff close together makes it more reliable, faster, easy to debug, and so on. So yeah, pick a cloud. It's not that easy, but there's plenty of them. Yeah. Okay, well, I'll be available for questions if you come up at the end, but if there's nothing else... Oh, there's one more at the back there, yeah. Sorry, I couldn't see him in the light.
So is this as fast as other solutions? So
as fast?
Yeah.
Well, speed is an interesting
Especially
thing here.
the function part.
I've gone for the easier for the programmer approach here. It's not necessarily the fastest. So if you were dealing with a really fast throughput of data, what I would do is put stuff in a queue, something like Apache Kafka, pull out things 1,000 at a time, deal with 1,000 things, write 1,000 things to a database. And that's a good way of dealing with huge throughputs of data. This is pulling one thing off the queue, writing it to a database, and then stopping, which makes it much easier for me, the programmer, but it's not necessarily the fastest performance.
Well, we tried this, I think, a couple of years ago, and what we noticed then is that if you have functions that are used not so often, the machine has to like spin up an instance. So if you have a function that is called like once an hour, for example, the performance of that function will be poor.
That is a very good point. So what the gentleman's saying there is that if you leave an action unused and it's maybe only run once an hour or something like that, the system will take down the container and allocate it to something else. So it gets a pretty large cold start, they call it. So, someone's called me, it'll have to load the container from disk and then start it up. But the second call to it will be really quick, right? It depends, if your application has a lot of traffic, then it'll always be ready to run. But if it's a very infrequently run service, you might suffer from a cold start. You can also keep things, you can reuse things in the same container. You can take advantage that containers get reused and store state inside the container so that the next process that runs it has already a connection to the database, say. And that you can do sorts of performance optimizations that way. But yeah, you're right, the cold start is a problem too.
Okay, thanks.
Okay, well, thanks very much for your patience, and enjoy your break and the rest of the conference. Thank you.